Welcome to the playlist of IIT-JEE Main Physics Part 2. The topic for the today's session is the conversion of a galvanometer into a voltmeter. And based on this topic, I have selected one question which was asked in the IIT-JEE Main examination in the year 2017. So the question here is, when a current of 5 milliampere is passed through a galvanometer having a coil resistance of 15 ohm, full scale deflection is seen. So the value of the resistance to be put in series to convert it into a voltmeter of range 0 to 10 volt is. So there are four options here and we have to find the correct one. So we all know that in order to convert a galvanometer into a voltmeter, we connect a high value resistor in series. And in order to convert a galvanometer into an ammeter, we convert a low value resistor, or we can say a shunt, in parallel to it. So here we have to convert the galvanometer into a this galvanometer into a voltmeter. So in this case, we will be putting a high value resistance in series to the galvanometer. So here, when a current of 5 milliampere is passed through the galvanometer having a coil resistance of 15 ohm, full scale deflection is seen. So this is let's say a galvanometer. Okay, and the coil resistance of this galvanometer is 15 ohm, or we can say the resistance of the galvanometer is 15 ohm. Now we will be putting a high value resistor in series to this galvanometer in order to convert this into a voltmeter. So this is the galvanometer, the coil resistance is 15 ohm, and let us say this is a high value resistor which is connected in series to this galvanometer. Now when a 5 milliampere current is passed through this galvanometer, a full scale deflection is observed. Now so we have to find the value of this this resistance which is put in series with this galvanometer. So now here the range of the this voltmeter is given is 0 to 10 volts. So the maximum value of the voltage is 10 volts, and if the resistance of this galvanometer is 15 ohm and the current which is passing through this galvanometer is 5 milliampere, therefore the potential difference across this galvanometer will be equal to 5 into 10 to the power minus 3 ampere. This is, I have converted this into ampere, into 15 ohm plus the potential difference across this resistor which is connected in series with this galvanometer. This will be equal to plus Rs into 5 into 10 to the power minus 3, and this will be equal to 10 volts. That is the potential difference across the galvanometer plus the potential difference across this resistor which is connected in series with this galvanometer in order to convert it into a voltmeter. So the sum of the potential difference across the galvanometer and this resistance will be equal to will be equal to 10 volts. So from here we can easily find the value of the resistance which is connected in series, and this is equal to 10 minus 75 into 10 to the power minus 3 divided by 5 into 10 to the power minus 3. So from here we can get the value as this will be equal to 2 into 10 to the power 3 minus 15. Or we can simply say that the value of the resistor which is to be connected in series with this galvanometer in order to convert into a voltmeter of range 0 to 10 volts, this will be equal to 2 into 10 to the power 3 minus 15. So this will be equal to 2000 minus 15. So this will be equal to 1985 ohms, or we can simply write it as 1.985 into 10 to the power 3 ohms. So the correct option here is D. That is, the value of the resistor which has to be connected in series with this galvanometer will have a resistance value equal to 1.985 into 10 to the power 3 ohm. So thank you very much for joining this session. In the next session, I will be coming up with a question in which we will be converting the galvanometer into an ammeter. So thank you very much again, and till the next session, have a nice day. Bye.